of other trig functions. All right, so today we're gonna look at graph of other trig functions. Let's look at y equal tangent of x and y equal cotangent of x. Those are the super easy one. Well, for tangent and cotangent, you don't have to look at 5 key points. You just have to look at 3 key points. For tangent, we just look at the 2 endpoints and the middle point. So the period for tangent is pi, and they're periodic for every pi. Same for cotangent. Period for cotangent is also pi, but they're a little bit different. Cotangent, since it's pi, the center is going to be at 0. Since its center is at 0, the endpoints are going to be negative pi over 2 to positive pi over 2. So the distance for these would be just pi. And all you have to do to understand it, it's an increasing function. And that's what it looks like. It's that simple. For cotangent, it's kind of the same, but starts at 0, ends at pi. So the midpoint is going to be pi over 2. And it is a decreasing function. So if I give you y equal tangent of 5x, how would we graph that? Period would be, again, this is your omega. General note for that would be pi over omega. That's the period. So in this case, it will be pi over 5. That would be the period. So how would we go about graphing this tangent? Center is going to be 0. So you do not put positive pi, 5 pi over pi over 5. That's not the right answer. The whole distance is pi over 5. So therefore, this is going to be pi over 10. What's half of pi? 5 pi. Half of pi over 5 is just pi over 10. So this is going to be negative pi over 10. And the graph is going to be like that. What if I made the problem a little bit interesting? Negative of that. Then this graph would change to this way. It's going downward. Let's do the same problem. Y equal negative cotangent of pi over x. I mean 5x. Period. We did that earlier. It's pi over 5. It's going to start at 0. It's going to end at pi over 5 because it started at 0. So the midpoint is going to be pi over 10. Cotangent normally would look like that. But because it's negative, it's going to flip. So therefore, it will look like that. All right, these are the easy one. So the hardest part would be graphing something like a equal y equal a cosecant of omega x plus b or y equal a times secant of omega x plus b. Graphing these. Well, if I give you this type of graph right away, these are very difficult to graph. But we can graph these if I give you this sine of omega x plus b, or y equal a cosine of omega x plus b. We could graph those. So let me go directly into one of the problem. Y equal 2 cosecant of x minus 1. Let's graph that. Well, right away, cosecant is hard to graph, but we can graph 2 sine of x minus 1. The one concept, one of the topic that might confuse you is this -1. This essentially tells you that it's a vertical shift. Since it's negative, it will go down 1. It will go down 1. And we'll come back and we'll explain that. First, let's graph this part. What's the period? 2 pi over omega. Omega is, in this case, is 1. What's the amplitude? 2. So let's graph this sucker. So let's graph. So it's going to go from 0 to, let's say, 2 pi. Halfway roughly would be somewhere over here. We don't have to be exact, all right? 1, 2, 1, 2, 3. So if I'm graphing this, my points, it's going to, sine starts at 0. Then it goes up to 2, then down to 0, then -2, that. This is what my graph would look like. This is what my graph would look like. Well, to graph now cosecant part, you have to do wherever you see this x-intercept, you draw vertical asymptotes. And wherever you see this maximum point, you have the parabola. And I just erased this. So I've just graphed this part right over here. Now, what is that -1 does? This -1, it just shifts it 1 down. So I grab that, I shift it 1 down. 1 down. And this is the graph of y equal 2 cosecant of x minus 1. Now, let me make the problem a little bit more interesting. Let's graph y equal -3 secant of 3x. Let's do that. For that one, let's graph -3 cosine of 3x. Well, let's graph this guy. Oh, before we do that, amplitude is 3 and starts at the bottom. Period is going to be 2 pi over 3. So if I'm graphing this, it's going to go 0 to 2 pi over 3. Where are my special points? Right over here is going to be pi over 3. Quarter is going to be pi over 6. This one is going to be pi over 2. 1, 2, 3, 1, 2, 3. So cosine starts right over here. So this is my cosine. Well, what do I know that? For this secant and cosecant function, for during the x-intercept, that's where you have the vertical asymptotes. Erase that. It's that simple. Now, this is one period. It doesn't mean that it's done. If I would have continued it, my graph would have looked like that. Then it would have looked something like that. I just chose to draw one period. Let's do another problem. Y equal -2 sine of 4 pi x. This is a difficult one. Amplitude again is going to be 2, and since it's sine, it will go down from the start. What about the period? Period in this case is going to be 2 pi over 4 pi. It just becomes 1/2. It's that simple. So if I'm graphing this, so it goes 0 to 1/2, 1/4, 1/8, 3/8, 1, 2, 1, 2. Since we're dealing with sine, it's going to go done. But what if I would have given you the problem y equal -2 cosecant of 4 pi x? What would that graph look like? Well, it's super easy. At the x-intercept, you have the vertical asymptotes. And at the min and maximum point of the graph, you get this nice parabola. That's it. All right, guys. You guys are doing really good. I'm noticing it. Some of you are still enrolled in the wrong class. I don't think it's good. Try to enroll in the right class. If you have any questions about the due dates, call me or email me. Those are getting updated every week. Don't fall behind. So as I've noticed, you have a bunch of assignments due this week. If you don't have any question, I'm going to stop my lecture right now.